All right, we're going to jump through to question number 8 in the static equilibrium worksheet. So here it's a bit of a different situation. Actually, this is like our equilibrium force type of example. So we have 3 forces pulling on a ring. So you can imagine that we've got a ring, and you've got force 1, force 2, force 3, and it's going to be moving around, obviously, depending on the size of the forces. So there's a 4th force that's being applied, and I'm just making up these directions right now, but this 4th force is that restoring force, the equilibrium force that will make F net 0. So that's kind of what we're looking for. The unknown force is the FEQ. All right. So we know the forces are coplanar, which means they really only occur in the x and the y axis. So we'll call them force 1, force 2, and force 3. So force 1 is 200 newtons at 30 degrees east of north. So 30 degrees east of north, you start north and go east, so that's F1. And if we have this being 30, then the angle must be 60 degrees north of east. And again, we want to always get our angle from the x-axis. The second force is 500 newtons, 10 degrees north of east. So I guess I better erase that 60. Okay, so we know that's going to be 60. We've got F2 going there, so that's F2, and that's 10 degrees. So that would be 10 degrees north of east, and we know that angle there for the F1 is 60 degrees. The third force is 300 newtons, 60 degrees west of south. So south, and we're going west, so there's F3. And if that is 60 degrees west of south, that must be 30 south of west. All right, so again, we know that F net has to be 0 newtons. And so here it's a matter simply of finding the F net. Now, we want it to be 0 newtons, but before we get to that, we do have to find the sum of forces. So F net is going to be F1 plus F2 plus F3. So this becomes a vector components question where we're going to add up F1x, F2x, F3x, F1y, F2y, and F3y, and get the total x and the total y, and then get the F net, and it's not going to be 0, and then we're going to have to add that FEQ, which will make it 0. So we'll begin. So again, if you remember our chart method that we had for this, for our vector components, we've got the vector, we've got x, and we've got y. So hopefully we're getting a bit more comfortable with visualizing how these work. So for F1, okay, we know that F1x will be F1, which of course is 200, so it'll be 200 times cos 60. Now if you used the 30 degrees east of north, then that would be sine 30. So I just made everything from the x-axis, okay, as we've been doing in the other examples, which is fine. You can absolutely do that. There's no issue. The y component will be, of course, the opposite side, which is 200 sine 60. Okay. F2 is also going up and to the right. So F2x would be 500 cos 10, and the y would be 500 sine 10. Okay. F3 is going down and to the left. If you go back here, it's going down and to the left. So F3 is 300 newtons, 60 degrees south of west. So F3x would be negative 300 because, of course, it's going to the left. F3 is going to the left. So that would be negative 300 cos 30. Again, remember I changed the angle. All right, it was given as 60 degrees west of south. Okay, but I made it 30 degrees south of west. So we measured the angle from the x-axis. Again, I just decided to do that, keeping in line with what we were doing before. If you want to keep the angles as given, then just make sure you use the proper cosine and sine ratios. So back to F3y. F3y is going down, so it's negative 300 sine 30 degrees. So now we got to find F net, which is the total. So again, like I taught you guys before, we just added up all the numbers. So we're going to go 200 cos 60 plus 500 cos 10 minus, because that's a negative, 300 cos 30. And you get 332.596. And it's a positive, which means the x is going to the right. So the F net x is 332.596 newtons. I'll put a positive just to emphasize it's going east or to the right. All right, so now let's carry on with the y total. So we'll clear the calculator here, and we'll add up the y's. So we're going to go 200 sine 60 plus 500 sine 10. And again, it's a negative, so we'll go minus 300 sine 30. And we get a positive 110.029. So 110.029. We know that's going positive north, so we'll put a positive there. So now we've got our x and our y for F net. So we do the final Pythagorean theorem. So F net x is going to the right, F net x, and F net y is going north. And we've got F net with our theta. So now we just do Pythagorean theorem, a squared plus b squared equals c squared. So F net will equal the square root of 332.596 squared plus 110.029 squared. And try to do this all in one step in your calculator to make it less buttons to press. So we'll go 332 decimal 332.596 squared plus 110.029 squared, and take the square root of that, and you get 350.323. So 350.323 newtons. Our angle, theta, remember inverse tan, opposite over adjacent. So 110.029 over 332.596, and we'll get our angle. So inverse tan, 110.029 divided by 332.596, and you get 18 degrees. So this ring is experiencing a net force of 350 newtons east, 18 degrees north. Now that's not equal to 0, so I'll turn the page here. If we just draw a quick free body diagram, we've got the F, and we'll call it the sum of forces, and that's what it's being equal to right now. It's not 0. Okay, we need to make it 0, so the only way to make it 0 is to have an equilibrium restoring force that's applied in the opposite direction. Remember, it makes an angle of 180. So that is our FEQ. All right, so if F net was 350 newtons east, 18 degrees north, the restoring force, FEQ, must equal 350 newtons west, 18 degrees south, or south, 78 degrees west. Sorry, south, 72 degrees west. And that is question number 8.